All right, so 7.3 is called solving trig or trigonometric functions. Okay, and what we're doing here, the goal here is to isolate the trig function, whichever function that is. It could be sine, it could be tangent, it could be cosine, it could be any of the reciprocal functions, whichever trig function it is you want to isolate. And then you want to find on your unit circle where that value exists. And then the answer is going to be the angle that matches that value. So it's really, we did something very similar to this when we did inverse trig functions, when you saw stuff like sine -1 of 1/2, right? Where you gave me the angle instead of finding the trig function. Or we did sine of theta equals 1/2, and so that you gave me the answer to that. For all of these, you're going to want to be able to reference your unit circle, either have it memorized, obviously, or have the little unit circle printed for yourself. But basically what I would do then is I would look at my unit circle and I would find which values or which angles in radians, so all of these are going to be answered in radians, which angles have a positive 1/2 for sine. So if you think about your unit circle, sine is the second term, right, which is the y, and sine is 1/2 at pi over 6 and at 5 pi over 6. So your answers are going to look something like that. The answers to these are going to be angles. The difference between when we did it the first time and now is that you're going to have to work to get that sine by itself. So it used to just be already by itself, and now we're going to have to work to get it by itself. When you answer these questions, there's two types of directions. One that just says solve, and then one that will say solve on the interval. If it's on an interval, you only use the interval that's given. So if it says from 0 to 2 pi, you only use your natural unit circle. If it doesn't give you an interval, then you do this, which is to the sine and cosine answers. For each angle that's there, you would add 2n pi. And what this means is that not only does that answer occur at that angle, but it occurs at every coterminal angle to that angle. So if I knew, which in this case, for example, that the sine of theta is, this would be root 3 over 2, good morning, 1/2, and this is pi over 6, right? If I know that sine is positive 1/2 there, if I go around the circle again, it's also positive 1/2 there. If I go around the circle again, it's also positive 1/2 there. So you're basically saying not only is it true for that angle, but it's true for all of its coterminal angles. So that is that 2n pi. N just represents a constant. It could be 1, it could be 2, it could be 3, it could be 4, whatever it is, okay? You don't have to change it. You just write n pi. For tangent, these things happen every half circle. So you add n pi. So again, sine and cosine, 2n pi. For tangent, you're going to add n pi. You don't have to go all the way around the circle. Again, you only go halfway for a tangent answer to repeat.
So in the answer, just say we have to add 2n pi, so would we just keep it as pi over 6 plus 2n pi?
Yep.
So we wouldn't have to add it?
Nope.
Okay.
Keep it exactly like that.
Okay.
Yep. All right, so again, these just say solve. There's no interval here, so I'm going to make sure that I answer with all the angles on my unit circle, and then to the sine questions, I'm going to add n pi, or 2n pi, and to anything that's got tangent, I would add 2n pi. Hang on, sorry, grabbing colors. Okay. So for number 1, I've got sine of x plus the square root of 2 equals negative sine of x. Is my sine of x isolated? Is it on a side by itself? No. So what do I have to do to get it there? You could subtract sine of s from the left. These cancel, and I get positive square root 2 equals negative sine of x minus sine of x would be? Negative 2 sine of x. Is sine by itself yet? No, I would divide by negative 2. So now it's saying where on your unit circle is your sine negative root 2 over 2. Now the better you know your unit circle, the faster it's going to go from here, but let's just say we're not familiar with it yet, especially because we're in the year of the COVID. Nobody has anything memorized because we all have reference sheets, okay? we would look at our unit circle and we would try to find where on this unit circle, let me group this before I zoom. Where on my unit circle is there a negative root 2 over 2 for y?
5 pi over 4 and 7 pi over 4.
Good. 5 pi over 4 and 7 pi over 4. Everybody sees that? Yep. Okay, so those are my two angle answers. 5 pi over 4, 7 pi over 4. And then to those, I'm going to add 2n pi.
So do you always add 2n pi, or is that only when there's no like
Only when there's, well, two things. When it's no interval and when it's sine or cosine.
okay.
So if the directions, then you'll see them change later on in the notes. It will literally say on the interval of 0 to 2 pi. And on those, you would only give the angles that are on your natural unit circle.
Okay.
All right, what's different with 2?
It's subtracting.
It's subtracting. So if I do the same thing I did before, and then divide by negative 2, I get the sine of x equals negative divided by negative, so square root 2 over 2. So now I'm looking at the other angles, right? Where it's positive, square root 2 over 2, pi over 4, and 3 pi over 4. And to those I add 2n pi. Now we haven't even begun to make the test that will consume this section, but I am assuming you will put them in the order that you have them, no spaces, okay, and you'll use pi for pi. So keep that in mind as you start to answer these. Yeah? Sure. All right, now look at 3. How do I isolate the trig function? What's the first thing you need to do? Add 1. So here's where it's weird. That squared is in between the tan and the x, but that actually, to get rid of it, I would square root it even before I do anything with that x. So from here, I'm going to divide by 3 because I want it by itself. Tan squared x equals 1/3. And then to get rid of the squared on the trig function, you'll just square root both sides. What do you have to do when you do a square root?
Plus 1.
Yep. So I get tan of x equals plus and minus the square root of 1, which is 1, over the square root of 3. Now, if this was one of the reciprocal functions, if this was secant or cosecant or cotangent, I would not rationalize yet. I would flip it first. But this is not that case, so I have to rationalize it. So I multiply by square root 3 in the top and the bottom, and I get the tan of x equals plus and minus square root 3 over 3. Now we're looking at all positive and negative square root 3's over 3's. So if you had added them onto your unit circle, what's the denominator of all the ones that have root 3 over 3? All the over 6's. So this is pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. It's all the over 6's. But remember, tangent, we add n pi to. Because tangent duplicates every half circle. Now think about what we've just done. We just said this one plus half the circle, which is 7 pi over 6. So we actually don't need the 7 pi over 6 because you're already saying it by saying pi over 6 plus n pi. it out is because we say tangent happens every half circle. So if I write, wait, hang on. So let me answer Madeline's question. So when you say pi over 6 plus n pi is half the circle. By saying pi over 6 plus n pi, we're also saying 7 pi over 6. And then the same is going to happen to 5 pi over 6. 5 pi over 6 plus n pi, so 5 pi over 6 is over here, right? 5 pi over 6 plus n pi takes care of 11 pi over 6, so we don't need that one either. So when you're dealing with a tangent, let's say, and it's got all 4 angles, you don't need them all. So tangent, when you're finding the angles, you only need to look in the first and second quadrants when it's not on the interval. So if it's on the interval 0 to 2 pi, you'll give all the answers that are there. But when it's like this and it's not on the interval, you only need to look in the first and second quadrants for tangent. So I could just go to these 2 angles and then add on the n pi. Of course, we're going to do lots more examples on this, so I don't want that to be like, oh, I don't understand it, because we're going to kind of clarify it a little bit. All right, so look at 4. Did I answer your question, Vanessa? Yeah, okay. So what would you do first for 4? Add the 3. Then what? Divide by 4. Sine squared x equals 3/4. Oh, what the heck? And then square root, good. So I end up with sine of x equals, and I have to do plus and minus. Plus and minus the square root of 3 over the square root of 4, which is 2. So now I would go to my unit circle, and I would find everywhere sine, which again is the y, is root 3 over 2. Positive and negative, which means it's going to be all of the denominators that are over 3. So over 3, over 3, over, oops, that's an over 6. Over 3 and over 3. So my answer here, pi over 3 plus 2n pi. 2 pi over 3 plus 2n pi. 4 pi over 3 plus 2n pi. And 5 pi over 3 plus 2n pi. So biggest mistake people make on those kinds of questions is forgetting the plus and minus.
Do we cross any of these out?
Nope, because think about what it is, right? Pi over 3 plus 2n pi, you would go back around your circle. It's not already on the circle. Anytime you disregard some as tangent or cotangent, right? And so the rule of thumb is instead of having to cancel them out here, you could literally just look in first and second quadrant. You don't have to keep going. Okay. All right, so again, these are like 2 different variables. We need them to get to be the same. You're going to go to your reference sheet. You're going to look for things that you can replace, okay? Right now, we can't replace it just yet. But if you think about what we've been doing with our factoring, if we get everything to one side, there's a common factor there, right? So if I move this over here with the other side, I get cotangent x, cosine squared x, minus 2 cotangent x equals 0. Then what's the common term there that I can factor out? Cotangent. So cotangent of x comes out, and I get cosine squared x minus 2 equals 0. So what has happened here is I've factored this into 2 different terms where if either of them are 0, the entire thing is 0, right? If cotangent is 0, it makes my whole line 0. If cosine squared x minus 2 is 0, it makes my whole line 0. So I actually can split and solve these. So I would get the cotangent of x equals 0 and the cosine squared of x minus 2 equals 0. So we've got our first reciprocal function, which is cotangent. We don't know the cotangents on our unit circle. You can add them on, and you can use them. Or I can flip this and make a tangent. So if I flip cotangent into tangent, what's the reciprocal of 0? Undefined. So do you remember where on your unit circle tangent is undefined? on the y-axis, which means the angle would be what? 90 and 270. So if I do 90 and 270 plus n pi, 90 plus 270 is 90 plus n pi is my 270. So I only need the top angle. So I would say this angle up here, which is pi over 2 plus n pi. Then I'd go to the right side and I'd say the cosine squared of x equals 2. Square root it and I get cosine of x equals plus and minus square root 2. Is there a square root of 2 in the cosine spot or in the x anywhere on my unit circle? No, there's root 2 over 2, but there's no square root 2. So when you get an angle that's not on your unit circle, you will rule it out.
Wait, then why can't we do the other thing with the cotangent?
What do you mean the other thing? Well, because there is a cotangent of 0. We just didn't write it on there. Like if you wrote it on there, cotangent would be 0 here and 0 here. It exists on your unit circle.
But couldn't there be a cosine?
There is a cosine of radical 2 somewhere on my circle, but not at my special angles.
Oh.
Yeah. So if you had a calculator, you could find this. I would do second cosine square root 2, keep my calculator in radians, I'd get an answer. But without a calculator, unless it is one of these special all the way around, I don't even use it. I don't answer it. Those plus the tangents. So if it's doesn't exist there, I cancel, I rule it out. I would need a calculator to find it. All right, go to 6. What could you do here? Oh, I'm so glad you did that. What happens when you divide both sides by sine is you eliminated an answer. So you can't cancel them out. You can move it to the other side. Sine squared x minus 2 sine of x equals 0. Then think along what we're doing, right? Could I factor this? What do they both have in common? A sine. So I take out the sine, and I get sine of x minus 1. And again, we factored it into 2 terms. Minus 2, yeah. Thank you. So then I split these and I set them equal to 0. So where on my unit circle is the y, because we're talking sine, is the y 0? At 0 plus 2n pi and pi plus 2n pi. And then on the other side, I'd end up with sine of x equals 2. Is there a place on my unit circle in which sine is 2? Nope. This actually would never work. Cosine, I don't know why I said it would. Cosine root 2 would never work because that's saying cosine's bigger than 1 and cosine can't be bigger than 1, remember? Sine and cosine can never be bigger than 1. Questions so far? Okay, for these, we're going to answer as if it's on the interval so that you can see the difference. So what do I do with 7? Factor it. If you need the a, like if I want to make a sine of x, because that's confusing, remember you can do this 2a squared minus a minus 1, then plug it back in. Hopefully the more practice you get at this, you could do it without that because it's an added step, but if you need it, do it. If not, I would take the factors of the first term, so 2 sine of x and sine of x. And then the factors of the last term, negative 1, in which the middle term is a negative 1. So if I did a positive 1 and a negative 1 here, and I did the outer and the inner, negative sine, 2 sine of x plus sine of x, gives me negative sine of x, and I know that's the right combination. So now, I'm gonna erase that so we have a clean space. I can split these, set them each equal to 0, and solve. So on the left, subtract the 1. Divide by 2. And I get sine of x equals negative 1/2. On the right, sine of x would equal positive 1. So now we go to the circle and only use these. So there's no adding of 2n pi this time. Where on your unit circle, we're talking sine, so where on your unit circle would the y be a negative 1/2?
7 pi over 6 and 11 pi over 6.
Good. And where would it be positive 1?
Pi over 2.
Good. So my answers are pi over 2, 7 pi over 6, and 11 pi over 6, if I had to put them in order from least to greatest. Okay, homework, PDF, you could just write it on there, but if you had to put it in order from least to greatest, that's how it would go.
Could you repeat that whole thing because my iPad?
Sure. All right, so I'm going to factor that 2 sine squared of x minus 3 sine x plus 1. Factors of positive 2 sine x would be 2 sine and sine. And then the factors of positive 1 that are going to give you that negative 3 in the middle are negative 1 and negative 1. Now I get a negative 2 sine and a negative sine, which gives me negative 3 sine. Now I'm going to split these, set them equal to 0. On the left, 2 sine of x would equal 1, and then divide by 2, and sine of x would equal 1/2. On the right, sine of x would equal 1. So then I'd go to my unit circle, and I want to find this time wherever the sign is positive 1/2, which is going to happen at pi over 6, 5 pi over 6, and where is it positive 1? Again, same spot, which is pi over 2. So if you're just giving these answers on a PDF, for the homework, then that's fine. If you're giving them as, like on your Canvas quiz, it will ask them most likely to be in the order of least to greatest, which would be pi over 6, pi over 2, and 5 pi over 6.
Can you just explain how you factored it one more time?
Yeah. So I did factors of the 2 sine squared x. And then look at the positive 1. My factors of positive 1 are either 1 and 1 or negative 1 and negative 1.
Okay.
The only way I'm going to get a negative 3 in that middle is if they're both negative.
But why wouldn't you multiply the 2 and the 1?
To do the first and last, you can do that.
Oh, okay.
Yeah, so then I would get 2 times 1, which is 2. Factors of 2 that sum to 3 would be negative 1 and negative 2. And then I would make are you doing A or are you keeping sine the whole time?
I kept sine.
Okay, so then it would be 2 sine squared x minus sine of x minus 2 sine of x plus 1. And then I would factor by grouping. From the first one, I'd take out a sine. From the second one, I take out a negative 1 because I need the signs to change. Then what's inside the parentheses is the same. And then what's left over gets grouped together.
Okay, thank you.
You're welcome. So the order might change depending on how you do that, but the answers should always be the same.
Okay. I'm confused. Because when the other one, what were the answers made of?
All right, so this is what I was doing before. Started doing it a little bit too early. Notice this time that there are 2 different trig functions, kind of like there was a little bit ago. But we can factor nothing out of here. So before it was different because we could factor them out, split them into 2 things, and solve them separately. But now there's no way to factor a sine squared and a cosine. So this is where your Pythagorean identities come into play. I need to replace one of those to make it the other one. So if you go back to your Pythagorean identities, sine squared plus cosine squared equals 1, which means I cannot replace cosine to the first, but I can replace sine squared with a 1 minus cosine squared. So I would get 2 times 1 minus cosine squared x plus 3 cosine x minus 3 equals 0. Now I have all one trig function. I'm going to distribute the 2 minus 2 cosine squared x plus 3 cosine x minus 3. I'm going to combine my like terms, negative 2 cosine squared x plus 3 cosine x minus 1 equals 0. So now I have to factor this. I've got a couple options. One is I can just straight up factor it using the negative on the front, okay? But most of us hate the negatives in the front. I'm one of them. I like to get rid of them. So you can either move everything to the right side of your equal sign and change the sign, or simply multiply everything by negative 1. And I'd...
Is dividing by negative 1?
Same thing, yeah. As long as you go all the way across the equal sign, and this time it's a 0, so it doesn't matter. But if there was a number there, we'd have to also make sure we change that as well.
Wait, and we did that so that the first one wasn't negative?
Yeah, you can factor it when it's negative. It just, people tend to mess it up when you go to solve it and there's a negative on the front.
Okay.
All right, so now I'm going to factor this. I can do the factors of 2 cosine squared x, which would be 2 cosine of x and cosine of x. And then factors of 1 again, this should look familiar, which are negative 1 and negative 1, or positive 1 and positive 1. The positive's never going to get me that negative in the middle, so it's negative. Check it. Outer 2 would be negative cosine. Inner 2 would be negative 2 cosine would be the outer 2. Inner 2 would be negative cosine, and that's negative 3. Now split and solve it. And it's 2 cosine of x equals 1. Cosine of x would equal 1/2. And cosine of x would equal 1. So now we're looking at our cosines. Which is our, oops, I just added the wrong thing, cancel. Which is our x values. So where on my unit circle are my x values positive 1/2? Pi over 3. And 5 pi over 3. And where is my x value positive 1? 0. So we always pick 0 because we're going to add 2n pi to it, or we pick 0 because if we get the interval, it will say 0 with a bracket on it and 2 pi with a parentheses, which means don't include 2 pi. So you always pick the 0 there. So the directions didn't say anything about interval, and I didn't add that on. So we're going to actually add on the 2n pi this time. So it's going to be pi over 3 plus 2n pi, 5 pi over 3 plus 2n pi, and 0, which is the smallest, plus 2n pi.
Do you have to keep the 0?
You actually don't have to keep the 0. So I could just write plus 2n pi. You just got to remember to put the plus there. Or, no, you don't even need the plus. You could just put n pi, 2n pi.
Okay.
Any of those would work. You just got to make sure you include it. All right, you try 10, and I'll give you a hint that you have to do the Pythagorean identities again. This time the secant and the tangent one. All right, so which one would you replace here?
Replace the secant.
Okay, it's actually a trick question because you could replace either. Okay, the catch with replacing the secant, the catch with replacing the tangent is that you would solve for secant, which is totally fine, and at the end you'd have to flip it to get its reciprocal, which would be cosine, which is fine. Extra practice though. If they had canceled out, it would have been no solution. Let's say that's a 3, right? So again, we're going to replace secant with tangent squared plus 1. So I distribute the 3 in there. 3 tan squared x plus 3 minus 2 tan squared x minus 4 equals 0. Combine my like terms this time. It's 3 tan squared x minus 2 tan squared x, and I get tan squared x. And then a positive 3 and a negative 4 is a minus 1 equals 0. With me so far?
Yes.
Now, move the 1 to the other side. Tan squared x equals 1, and square root it. Putting a plus and minus in front of that 1. So,
Could you also just like factor it and you get?
yeah, plus 1 minus 1. As long as you don't cancel them out, you could do that.
Okay.
Yeah. So I don't know if you heard it from home, but Vanessa asked, could you also take that, this is the difference between 2 squares, could you also factor it and set them equal to 0? Absolutely, that works too. So now I'm looking at my unit circle. Everywhere there's a tangent, that is a 1. But remember, tangent, we only need half the circle because we add the other half the circle. So if I only look at the first and second quadrant, which is what you want to do for tangent, where is it positive 1? Remember, this is our 0, this is our root 3 over 3, this is 1, this is root 3, this is undefined. It's 1, positive 1 at pi over 4, plus n pi. And where's it negative 1?
3 pi over.
Good, 3 pi over 4, plus n pi. Okay, we're going to stop there. We're going to finish the rest tomorrow. I just posted the PDF for you to do, but I want you to open it because I'm going to give you I'm going to tell you which ones that you don't have to do today, like the ones you can skip that we didn't get to. And I think there's one that matches what we just did. So I'm going to tell you that you can skip that one too. So again, you want to get that PDF open. That's now on your to-do list. So by skip, I should actually just say cross out. Completely cross out 4, 5, and 9, okay? Because they're duplicates of what we did in the notes. But for tonight, you want to skip these because we haven't talked about how to do those yet. So 6, 17, 18, 19, 23, and 24, don't do tonight. We haven't talked about how to do those yet. The rest you should be able to do. And again, I will put these on the instructions of the assignment. I just don't want to do that now because my screen keeps freezing every time I jump in and out.
So we do or don't do 6, 17?
You will, but not tonight.
Oh.
So for tonight, skip 6, 17, 18, 19, 23, and 24. Because you'll be confused. After tomorrow, you'll be able to do those. Just not yet. And I'm going to let you work. So you could choose if you want to work on something from another class, you want to work on this. This is technically no longer my class time. So feel free to use either of those. Obviously, I'd encourage if you want to get started on your homework and you don't have anything else you need to do that because I can answer questions while you're working on it. But if you want to work on something else too, that's fine. Just be productive human beings.